Hello everyone, I'm Ma'am Jackie and our topic for today is about wave optics. Wave optics is a branch of physics that deals with the study of light and other forms of electromagnetic waves. It involves understanding the propagation, interference, diffraction, and polarization of waves to explain various optical phenomena. Wavelength is the distance between two successive points in a wave that are in phase with each other. In the context of light waves, it represents the distance between two consecutive crests or thrusts of the wave. It is typically denoted by the Greek letter lambda and is used to characterize the color or frequency of light. Reflection occurs when a wave encounters a boundary between two different media and bounces back into a original medium. The angle of incidence is equal to the angle of reflection. Examples include how light bounces off a mirror or how sound echoes off a wall. Refraction is the bending or change in direction of a wave as it passes from one medium to another with a different refractive index. This change in direction is caused by a change in the wave's speed. The amount of bending depends on the angle of incidence and the refractive indices of the two media. Refraction is responsible for phenomena like the bending of light as it passes through a lens or the apparent bending of a straw in a glass of water. Diffraction refers to the bending or spreading of waves. Diffraction refers to the bending or spreading of waves as they encounter an obstacle or pass through an opening. It occurs when waves encounter an edge or an aperture that is comparable in size to their wavelength. Diffraction can lead to the spreading out of waves beyond what would be expected based on geometric optics alone. Light as an electromagnetic wave. According to the wave theory of light, proposed by scientists like Christian Huygens and later supported by James Clerk Maxwell, light is composed of oscillating electric and magnetic fields that propagate through space. These fields are perpendicular to each other and perpendicular to the direction of the wave. The wave characteristic of light refers to the understanding of light as an electromagnetic wave. Light is a form of energy that can exhibit wave-like properties such as diffraction, interference, polarization, and refraction. The video clip shows how transverse wave look like as viewed from above and from the side. A light wave can be imagined to propagate this way. Although we do not actually see it wiggling through space, a transverse wave such electromagnetic wave like light consists of electric and magnetic field. Therefore, the side view graph could be the graph of electric or magnetic field. Huygens Principle. Huygens Principle is named after the Dutch scientist Christian Huygens. It is a concept in wave optics which states that every point on a wavefront can be considered as a source of secondary wavelets, and the future position of the wavefront is determined by the envelope of these secondary wavelets. This illustration depicts Huygens' principle applied to a straight wavefront. A wavefront is the long edge that moves the crest or the throw. Each point on the wavefront emits a semicircular wavelet that moves a certain distance s. The new wavefront is tangent to the wavelets. Huygens' principle works for all types of waves including water waves, sound waves, and light waves. The principle is useful not only in describing on how the light waves propagate, but it is helpful in explaining the laws of reflection, refraction, and diffraction. The Huygens principle also tells us how and where light rays interfere. The figure shows Huygens' principle applied to a straight wavefront striking a mirror. The wavelets shown were emitted as each point on the wavefront struck the mirror. The tangent to this, wavelet shows that the new wavefront has been reflected at an angle equal to the incident angle. The direction of propagation is perpendicular to the wavefront as shown by the downward pointing blue arrow. The law of refraction can be explained by applying Huygens Principle to a wavefront passing from one medium to another as shown in the figure on your screen. Each wavelet in the figure was emitted when the wavefront crossed the interface between the media. Since the speed of light is smaller in the second medium, the waves do not travel as far in a given time, and the new wavefront changes direction as shown. This explains why a ray changes direction to become closer to the perpendicular when light slows down. Huygens Principle applied to a straight wavefront striking an opening. The edges of the wavefront bend after passing through the opening. This is a process called diffraction. Since wave characteristics are most apparent when interacting with things of the same size as the wavelength, the amount of bending is greater for a small opening. Thomas Young performed the double-slit experiment and proven that light is a wave. In the double-slit experiment, a source of light or particle is directed toward a barrier with two small slits. Behind the barrier, there is a screen or detector that captures the pattern produced by the particles passing through the slits. The key observation is that even when individual particles such as photons or electrons are set through the slits one at a time, an interference pattern emerges on the screen. Interference. Interference refers to the phenomenon that occurs when two or more waves interact with each other. When waves meet, their amplitudes or the heights can add together or cancel each other out, resulting in constructive or destructive interference, respectively. Constructive interference. Constructive interference happens when the peaks of two waves align, leading to an increase in amplitude. In this case, the waves reinforce each other, resulting in a larger combined wave. And when this happens, the resulting wave has a higher intensity or brightness. The green light in the figure shows the pure constructive interference. A pure constructive interference is obtained when identical waves are in phase. Destructive interference occurs when the peak of one wave aligns with the throw of another wave. In this case, the waves cancel each other out, leading to a decrease in amplitude or complete elimination of the wave. The resulting wave has a lower intensity or brightness. The dark spots in the figure depicts a pure destructive interference. A pure destructive interference occurs when identical waves are exactly out of phase or shifted by half a wavelength. To understand the double-slit interference pattern, we consider how two waves travel from the slits to the screen. When waves, such as light waves, pass through the double slits, they diffract and spread out as they pass through the slits. These diffracted waves then interfere with each other when they reach a screen placed behind a tiny opening. So you can see the bright and dark spot projected on the screen. These are the bright spots and these are the dark spots, or also called bright fringes and dark fringes. The bright fringes, also known as maxima, correspond to constructive interference, where the peaks of the waves from the two slits align and reinforce each other. The dark fringes, or minima, correspond to destructive interference, where the peaks of one wave aligned with the throws of the other, resulting in cancellation. The spacing between the fringes in the interference pattern depends on the wavelength of the waves and the distance between the slits. When the distance between the slits is small compared to the wavelength of the waves, the fringes are closer together. As the distance between the slits or the wavelength increases, the fringes become wider apart.